Today's lesson will be on the relationship between the angles and the sides of a triangle. Okay, now we have this triangle ABC, and the angle at the vertex A, right, we'll call it angle A. The length BC, which is opposite angle A that we see in the diagram, we'll call it small a. The angle at vertex B is called angle B, and the length which is opposite angle B is the length AC, and we'll call it small b. The angle at vertex C is called angle C, and the length which is opposite this angle will be the length AB, and we'll call it small c. Now let's see if there's any relationship between an angle and the opposite length of a triangle. We have a triangle ABC with the given angles as well as the given lengths. Now let's calculate the value of A over sine A. Now A is the length 8.2 and sine A will be sine of the angle 68.1 degree. Now using your calculator, right, we should be able to get the value of 8.84 by calculating 8.20 divided by sine 68.1. Now let's calculate the value of B over sine. The length opposite angle B, which you see in the diagram, is the length small b, which is the length 8.04. B over sine B will be the value of 8.04 over sine 65.5, which should also give you the value of 8.84. Now we should now do the same thing for C over sine C, C which is 6.4 and angle C which is 46.6. Now by calculating the value of C over sine C, which is 6.4 over sine 46.4, we will also get the value of 8.84. Now let's look back at all the values that we have calculated. A over sine A, B over sine B, and C over sine C will all give the same value of 8.8. Now the small a that we have used, right, that length will be the length that is opposite the angle A. The length B that we use to calculate B over sine B, that will be opposite the angle B that we see in the diagram here. Same goes for C, the small length C. This length is opposite the angle C that we see in the diagram. Now here we have a new triangle ABC with different angles as well as different lengths compared to the previous triangle that we have used. Now we are going to use this triangle to calculate the value of A over sine A, B over sine B, and C over sine C, and see whether there's any relationship between these three values. Okay, now students, please take out your calculator and calculate the value of A over sine A, B over sine B, as well as C over sine C to see whether there's any relationship between these three values. So what is the value that you have gotten for A over sine A, B over sine B, and C over sine C? Now the value of A over sine A, B over sine B, and C over sine C, right, all will give the same value of 11.6. Okay? Now let's recap what we have learned so far. Using the two examples of triangle that we have seen so far, okay, we see that the angle that we use and the length opposite the angle, right, there is a relationship. Okay, and when we calculate the A over sine A, B over sine B, and C over sine C, right, we see that all the values will be the same. Now this relationship that we can see, right, in any triangle that we use, right, is called the sine rule. And the sine rule is that the value of the A over sine A, B over sine B, and C over sine C, right, they will all give you the same value.